Tried to color all around, all is new in the Savior I have found. Oh, this is living now. This is living now.
Hi everyone! Welcome to this pre-calculus tutorial. I'm Norlan Mallari from grade 11 Ernest RUTHERFORD, and we're here to talk about proving divisibility by mathematical inductions. If you have comments, just comment below. Thank you and enjoy the video.
Let's give a short review of mathematical induction. Mathematical induction is a proof technique to prove given statements of sets of real numbers, sequences, situations, etc. It has these components and steps. The conjecture, or the statement we will prove whether or not it is true. It is a formula in this case, where we will substitute an integer to an unknown variable. The base case or basic step, where we will see if the conjecture is true for the first natural number, 1. The induction hypothesis, where we will assume that an expression is true. Inductive step, where we will substitute k plus 1 for the variable to see if it is true for the next natural number. And lastly, the conclusion. If it is true, we'll tell p of n or the given conjecture is divisible for the given number. We will use the symbol of the vertical line, which means divides or is a factor of. Like in the given mathematical statement, it literally means 3. Let's start with this conjecture. Prove that 3 divides 4 raised to n minus 1 for all positive integers n. First, we'll do the base case. Substitute 1 for n in the formula, then simplify. So 4 raised to 1 minus 1 is 3, and 3 divides 3. So let's end this step with our conclusion for this step. 3 is divisible by 3. Now let's proceed to the second step. Next is the inductive hypothesis, where we will substitute k to the variable n in the original formula. Since we have proven in the first step that it is true, we will let the formula, which is now 4 raised to k minus 1, as a number divisible by 3, concluding with 4 raised to k minus 1 is divisible by 3. We replace k with k plus 1, making it 4 raised to k plus 1 minus 1. We need to look for 4 raised to k minus 1, or 3, or 0, for these are the numbers that are divisible by 3. And yes, 0 is divisible by 3, giving us 0. But 3 is not divisible by 0, it is undefined. Now this is a tricky question. Remember that in the laws of exponents, if we multiply, let's say, 2 raised to 1 with 2 raised to 2, we will come up with an answer 2 raised to 1 plus 2, which equates to 2 raised to 3, which is 8. We only add the exponents of 2 digits multiplied, which have the same base. If we apply it here and say that k and 1 are exponents of different multiplied numbers with the same base, so we can say 4 raised to k plus 1 is the same as 4 raised to k times 4 raised to 1. I repeat, it's based on the product rule of the laws of exponent. Let's proceed. We will factor 4 raised to k plus 1 to 4 raised to k times 4 raised to 1, and then the minus 1. But we're looking for 4 raised to k minus 1, and we can simply switch the places of 4 raised to k and 4 to make 4 raised to k appear nearer to minus 1, since we still would have 4. But we do have 4, which is a whole number. We can factor 4 into 2 digits. When added or manipulated, we'll have 3 as one of its addends, and the 2 digits will result to 4. For example, 3 added to 1, or 3 plus 1, in this case in this problem. Then we'll write it as 3 plus 1 times 4 raised to k minus 1. Then we can make it as 2 terms. The first term is 3 multiplied to 4 raised to k, plus the second term, 1 multiplied to 4 raised to k, which is 4k. It is not 4 raised to k plus 1 because 1 and 4 raised to k doesn't have the same base, and minus 1. Did you see that 4 raised to k minus 1 is there? Yes, and the other digit has 3 as a factor since it is multiplied by 3. So the resulting statement is divisible by 3. We can now conclude. Conclusion. Since the conjecture is proven true, we can write that, thus, 4 raised to n minus 1 is divisible by 3 for all n which is greater than or equal to 0. And now for the synthesis. In proving divisibility through mathematical induction, we prove the conjecture first with the base case. We substitute 1 for the variable in the formula to check if it is real at the first natural number. Next, we do the inductive hypothesis, where we substitute k with the variable in the original formula. Next, we do the inductive step. We substitute k in the second formula with k plus 1 to see if at the next integers it is true. Then we manipulate the formula. We make the terms divisible to the number the conjecture says divides it. Then we conclude. I hope you learned a lot. Thank you and enjoy your day. Don't forget your questions and comment them below. Thank you.